Okay, for the first section in topic 3 here, we're going to go over some set theory and Venn diagrams. This is pretty straightforward stuff, but if you can make a Venn diagram, there's often going to be a lot of problems on these, like especially like probability and stuff like that. But as you can see, there's a bunch of symbols that you need to know. Union, that means everything together. Intersection obviously means things they have in common. Element, not an element. Subset, complement, that means not. Like anytime you see that right there, it means not. Universal set, that means everything in all the sets. Okay, so the best way to do these is just so let's start and do it. So it says the sets P, Q, and R are subsets of U, defined as follows. Okay, so positive integers less than 13 is U. Okay, I always like to write that out. So that's just going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now, make my bad set brackets like I always do. Woo. Okay. Now, the prime numbers. Remember, 1's not a prime number. Okay, so they want us to list the elements of P, Q, and R. So I'm just going to do them right here. Okay, so no, 1's not a prime number. So we start with 2, 3, 5, 7, and 11. Remember, the prime number just has two factors, one in itself. Factors of 18. Now, with that, I would just go like this. 1 times 18, 2 times 9, 3 times 6. So which ones are below 12? Well, it's going to be 1, 2, 3, 6, and 9. So we will go 1, 2, 3, 6, and 9. Okay? And then multiples of 3. Multiples of 3 is just skip counting, so we'll go 3, 6, 9, 12. And we're good to go. Now, this here says they want the intersection of P, Q, and R. Okay, so the intersection of P, Q, and R. Well, let's look what they have in common. Just looking here. Well, they all have a 3. Okay, so 3, 3, and 3. Anything else? 5, 7, 6, 9. 6, 9. No, these don't have a 6 or 9. So it's only 3. So that's your answer right there. Okay? So it's 3. All right, so let's move on from here. Okay, for part B, it says draw a Venn diagram showing the relationship between the sets U, P, and Q, U, P, Q, and R, and write the elements. Okay, well, I've already done this right here, so let's just take a look at this real quick. What 3 is, you always, in a Venn diagram, you always work out, I think of LFMAO, you work out from the middle. So 3, I would put that in first. Now, P and Q have a 2 in common, and then P only, has 5, 7, 11. That's only in P, and then Q has 1. And then Q and R have 3, 6, and 9 together. And then don't forget to put all the ones that are not in either set. You need to put those out there. So 4, 8, and 10 are out there. Just go through one thing at a time. I would just go 1, 2, 3, 4, and then just put them in. And it's pretty straightforward. Most kids get this right. So what they're going to ask us to do now is they're going to ask us to shade some things here. Okay, well, first they're actually going to say, from the Venn diagram, list the elements of P union intersection Q and R. So P is going to be this whole circle right here, this whole P right there. Now, the intersection of Q and R is right here. Okay, so if we look at this, this is a union problem. Okay, so we have P, and then we have R right here. Now, it's a union, so we take them all together. So we're just going to list all those right there. So we got, I'm going to put them in order, but you don't have to. 5, 6, it makes it easier on the person grading. 7, 9, and 11. And just make sure I have all those 6. 1, 2, 3, 4, 5, 6. Oh, shoot, there's a 2 there. 2 also. I almost missed one. So 2. Okay, so we're good to go on that one. Now, not P union R. Okay, so P union R is right here. So they're saying everything that's not P union R. So, what they're looking for is, not P union R. So they're looking for this right here, and they're looking for these right here. So the elements of that would be, 1, 4, 8, and 10. Okay? And then not union P union Q. Okay, so not P union Q and not R. Okay, so not P union Q. I'm just going to write these down because it's going to be a little easier. It's getting kind of muddled in here. So not P union Q would be, 4, 8, 10, and 12. And then that's the intersection with not R. Well, not R is, that's a lot of them. It's, 4, 8, 10, the outside ones, plus all P and Q. But we know it's not going to be part of that. So if we just look at this, it's going to be, 4, 8, and 10. That's going to be our answer. Okay? Now, now we'll do a little shading. Okay, so on separate Venn diagram, shade the following. Now, I did these on a piece of paper, and I just pasted them in here for the sake of time. So the intersection of P and Q. Okay, so PQ. Just remember you have to shade both of them, so it's right in here. That one's not too bad. Union of Q and R. Well, that's just going to be all of Q, right here, and all of R. Okay, so we're good to go there. Those are pretty easy. Now, union of P, Q, R, that would be all three circles, but it says not. So that's just going to be the outside right there. Okay, and finally the last one, P intersection not R. So not R is going to be all the stuff out here, and it's intersectioned with P, so they have to be in the same thing. So it's just going to be that right there. Okay, so shading in Venn diagrams, it's not that bad. If you can do it properly, these are some easy points. This might be worth I don't know, 4 points and another 4, say like 8 points, 8 marks on a test, which is kind of a lot. Okay, so what I'm going to do on the next couple problems is make a couple more Venn diagrams just to make sure we're square on that. Okay, so I said this before, but it bears repeating. When making Venn diagrams, think about LMFAO. You always need to work out, which means you always work from the middle of the Venn diagram to the outside of it. So we're going to make a Venn diagram for this data here. Okay, and I'll make it nice and big and not very neat. Always make sure you draw your rectangle around that. That's actually, believe it or not, in every mark scheme that's worth 1 point. And I have kids who just won't do that, and they get dinged every time. Okay, so it says Fatty's Delight sells chicken. Okay, they sell chicken, duck, and barbecue. Pork rice of 160, 57 had chicken rice, 60 had duck rice, 48 had barbecue pork rice, 30 ordered chicken and duck, 25 ordered duck and barbecue, blah, 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 35 ordered chicken and, okay, whatever. All right, so this is the important part, is, starting from, like I said, the middle. So 20 ordered all three. Okay, so we're going to put 20 right there. Okay, now, the thing is, it says, 35 ordered chicken and barbecue. Okay, well, okay, we don't put a 35 there, because if they said chicken and barbecue only, then we would put a 35, but we don't. So we need to actually do 35 minus 20, which is 15. So we need to put that there. Okay, now 25 ordered duck and barbecue, so it's 25 minus 20, which is 5. Okay, and then 30 ordered chicken and duck, so that's going to be 10. 30 minus 20 is 10. Okay, now 30 ordered chicken and duck. So 30 ordered chicken and, wait, hold on, whoops, sorry. 48 ordered barbecue pork rice. Okay, well this is, 25, 40, so this one's going to be 8 right here. And if you add all these up, it's going to equal 48. 60 had duck and barbecue, so that's what? 30, 35, so that's going to be 25 to get to 60. And then, what do we have? 57. So we have 30, 45, 57, so that's going to be 12. Now, if you add all those up, there's 160 customers. We want to know how many didn't have rice. And if you add all these up, it adds up to 95. So if you do 160 minus 95, you get 65. And that's, the numbers that didn't have anything. So, you want to make sure you're good with that. So find the number of customers, so let's answer these questions, who ordered more than one type of rice. Well, more than one type of rice is just going to be, anyone who ordered 2 or anyone who ordered 3. So it's, it's going to be 10 plus 20 plus 15 plus 5, which would be 50. And we're good there. Did not order a rice dish. Well, we already did that. That's 65. Did not order chicken rice. Okay, so did not order chicken rice. So here's chicken rice. So it's going to be, 25. You just take everything that's not in there. Plus 5, plus 8, plus 65. Excuse me. So that's going to be 103. Make sure you count the outside one. In order, duck rice and one other rice dish. Well, duck rice and one other would be right here and right here. So that's just going to be 10 plus 5, which equals 15. And you're good to go. So that was pretty straightforward. And let's do one last one with a little bit of algebra in it. Okay, it says in a club with 70 members, everyone attends either on Tuesday for drama or Thursday for sports, or on both days for drama and sports. 1 week it found 48 members attend drama, 44 attend sports, X members attend both. Okay, draw and fully label a diagram to illustrate this data. Okay, well, no problem. We have, this is actually only a 2 circle Venn diagram. We have drama here, and we have sports here. So drama and sports. Now, they say that the X is they attended both, so X is going to be here. Now, this is where kids get a little confused. Okay, it says 48 attended drama. Well, this is not going to be 48. It's going to be 48 minus X. And then, sports is going to be 44 minus X. Now, find the number of members who attend both drama and sports. Okay, well, there's 70 total members here, so we can just use a little bit of algebra. 48 minus X plus 44 minus X equals 70. So what's this? We have... Okay, so I'll put these together. So those cancel out. Okay, so we get negative X plus 92 equals 70. So we subtract it, we get negative X equals negative 22. Well, okay, so X is going to be 22. Okay, so the middle is going to be 22. And describe in words the sets represented by not D intersection S. So what they're talking about there with not D intersection S is they're talking about this right here and this right here. So this is people who did drama only or sports only. Okay, and there you go. So Venn diagrams. I'm going to do another one with the probability in just a couple minutes. But if you can get those down, it's some pretty easy marks for you. And don't let the algebra confuse you. Sometimes they throw those in there. They can be a little more difficult. But just remember, this whole thing has to add up to 48. If this is X, you just got to take away X here. That's basically how they always work. Anyway, hope this helped out. We'll move on to the second topic now, logic. All right. Okay, for the second section here, we got logic symbols and statements and truth tables. Logic is a topic where you can earn easy marks. You must know the following symbols, though. So this is negation, not. This is and. This is just like the logic symbol, or not the logic, the set symbol that looks like that. This is disjunction. This is or. Then or but not both. If then, if and only if. A converse is if you have implication. A converse is when you just switch them. So like P then Q becomes Q then P. Inverse means that you negate them both. Contrapositive means that you switch the statements and then you negate them both. You have to memorize this. You just have to. Because you're giving away points if you don't. Now, here are the most common truth tables. So, the thing with and, P and Q, it has to be true to be true. P or Q, it only has to have one true. So, this is the only false right here, and this is the only true right here. P or Q, but not both. Well, that can only be one, so you're only going to have true on those two. If then. Now, the thing with if then is true false. True false, true false right here. That's never going to work with implication. And then or but not both. That's just going to be true or false false. Okay. Now, the one thing to remember with implication is that true false is always false. The rest are true. And if the column is all true, it's called a tautology. If it's all false, it's called a logical contradiction. And if the two columns are identical, then they are considered logically equivalent. Now, oftentimes on paper 2, they'll ask you one of these. Paper 1, paper 2, I don't know. I've seen them on both. And, they'll ask you to fill in a truth table. And, then they'll ask, oftentimes it's a tautology, and they'll ask you to do that. So, it's really important that you guys know this, and because it is easy marks. Okay, so let's go ahead and do a problem here. It says copy and complete the truth table to show that not P or Q, then not P and not Q is a valid argument. Okay, no problem. So P or Q. So remember, it only has to be one. So it's going to be, true, 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 and then false. Now, not that. Okay, fine. That's just going to be the opposite of this. So it's going to be false, 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 true. Now, they do the nots here. And remember, and has to be true, true. So this is going to be false, 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 and true. And then we go from not, okay, so this column right here to this column right here, and it's implication. So, false, false is true. False, false is true. False, false is true. And true, true is true. Okay, so this is a tautology or a valid argument. Okay, so tautology because it's all true here. Woo! Okay, that was a horrible bracket. Okay, let's try another one here. It says the following propositions are given. The train leaves from gate 2, P. Q, the train leaves from gate 8. The train does not leave today. Write a sentence in words the following statement. Okay, so remember, anytime you see implication, you have to put the if then. So if P, the train leaves from gate 2, the train leaves from gate 2, okay, then, so if then is worth 1 point, that first part would be worth 1 point as well. Okay, so what does this say? It's not leaving today, and it's not leaving from gate 8. Okay, so then it, so if the train leaves from gate 2, then it does not leave today. So then it leaves today. So it's not. That's kind of confusing. And does not leave from gate 8. I think, yeah, from gate 8. Okay, so there you go. There's a lot of leeway on those, by the way, so just, do the best you can to say what it means. That's kind of, I don't know, those are weird. Write the following sentence in a logic argument using P, Q, and R in logic notation. So if the train leaves today, the train leaves today if and only if, okay, well, if and only if is going to be that. It leaves from gate 2. So if the train leaves today, so that's going to be not R. And then it leaves from gate 2 or from gate 8. So that's going to be P or Q. And make sure you put the brackets there in the end of that. And you're good to go on that. So, this is what logic is, and if you get good at it, I'll do one more. Or actually, how many more do I have? I have one more. So hold on just a second. Okay, so in the last one here, I just want to do some converse, inverse, and contrapositive in symbol and word form, just to get going here. So write the converse, inverse, and contrapositive in symbol and word form for if P then Q. Okay, no problem. So the converse is just when you switch it. So it's going to be Q then P. And how would we say that? Well, I will get a high mark on the test. Or if I will get a high mark on the test, then basically I studied for the test. I'm changing the verbiage. I made this one up, so it's not the best one in the world. Yep. Okay, so the inverse is you keep the order, but you negate them. So not P, then not Q. So in that case, it would be, if I did not study for the test. Don't you love my handwriting? It's awesome, huh? Then I did not get a high mark. Okay? And then finally, we'll switch them and negate them. So not Q, then not P. So that would be if I don't get a high mark on the test, then I did not study. Now, let that be a lesson for you. Study hard. Study hard. Okay. And you'll get a high mark. Woo. Okay. Anyway, there you go. So, logic, I have to say, it's mostly about memorizing, and it's easy marks. So you memorize this stuff, you are good to go. All right. Let's move on to the last thing, probability. Okay, in this problem, or this section, I'm going to go over probability. Now, I'm going to do quite a few problems on this. Probability, it comes in a lot of different forms. So, if you have some issues with this, I'm going to try and do as many different problems as I can. This might take a while, but hopefully it's worth it. Many probabilities are actually quite simple. Simple probability can be represented by the formula, the probability of A equals the number of A over the total number. All probability answers will be between 0 and 1 and might be expressed as a fraction. Don't worry about reducing the fraction. So that's one thing where kids kind of make some mistakes. They get the right initial fraction, then they reduce it wrong, and it's just a waste of time. So let's look at an example, a pretty straightforward one here. It says Heinrich rolls 2 6-sided dice at the same time. One die has 3 red sides and 3 black sides. The other is from 1 to 6 by means of a tree diagram, table of outcomes, or otherwise answer the following questions. Okay, well, this one, you're best off making a grid, I think, personally. That's an awesome line right there. That is horrible. Okay, so, die 1 here, you have red, and you have, what is it? Black. Okay, black, and then you have 1 through 6 here. Okay, now, a common mistake kids made on this is they put 3 reds and 3 blacks, and that's actually not, red or black doesn't matter, it's the same outcome. So it doesn't matter which red or black you get. Okay, there's only 2 outcomes. So if you draw the little dots here, and how many outcomes are there? Well, there's 12. A lot of kids in this problem, I gave this to my kids in a test, and they put 36. The answer is 12. What's the probability here to roll a red in an even number? Okay, well, let's use a red pen for that. A red in an even number. Well, okay, here's red, and then here's even numbers, 2, 4, and 6. So that's just going to be 3 out of 12. Okay. What about red or black and a 5? Okay, well, red or black and a 5. Well, it has to be a 5 here, and it's red or black, so that's just 2 out of 12. And again, don't reduce them. What's the probability it rolls a number less than 3? Okay, well, a number less than 3 is just 1 or 2, so it's going to be that one, that one, that one, and that one. Well, that's 4 out of 12. Boom, done, easy. Okay, so that's simple probability right there. Let's do another one. Okay, so it says part C in the next problem contains conditional probability. Conditional probability can almost always be done logically. Just remember that the denominator will always be smaller than the total in these problems. Okay, no problem. We'll get to that in a second. It says on a certain game show, contestants spin a wheel to win a prize, as shown in the diagram. The larger angles are 40, the shaded sectors, okay, and the smaller angles are 20. Okay, no problem. Now, the thing you got to know here is that a circle has 360 degrees in it, right? Okay, so find the probability that a contestant will not win a prize. Well, that's going to be 1, 2, 3, 4, 5, 6 times 40, which is 6 times 40 is 240. So it's going to be 240 out of 360, and you just leave it. Don't even reduce it. We'll win a Greek holiday. Okay, we'll win a Greek holiday. Let's see, Greek holidays right here and right here. Are there any more? No, and those are 20. So 2 times 20 is 40. So that's going to be 40 out of 360. Okay, now here's conditional probability on the next one. Okay, so it says we'll win a washer dryer, given that he's won a prize. Okay, well, how many prizes do we have here? We have 1, 2, 3, 4, 5, 6. So our denominator is 6 times 20, which is 120. So that's going to be on the bottom. Now, which one of those are washer dryers? How many are there? There's 1, 2, 3. So it's going to be 3 times 20, which would be 60 out of 120. And you're good to go on that. And then the last one, again, is you just have to add 2 things. Now, this isn't conditional probability. It goes back to being simple probability. We'll win a holiday in Greece or a washer dryer. Well, okay, so holiday in Greece or a washer dryer. Let me get a different color for that. So Greek holiday, washer dryer, Greek holiday, washer dryer, washer dryer. So they don't get the card. Oh, too bad. So 5 times 20 is 100 over 360. Okay, so that takes care of simple probability. Let's move on now to some independent probability. Okay, I lied. I want to do one more simple probability, and this one's from a table. The table below shows the number of left and right-handed tennis players in the sample of 60 males and females. If a tennis players are selected at random from the group, find the probability that the female and left-handed. Okay, well, left-handed female is right here, so that's just going to be 40 out of 60, or it's not 40, 4 out of 60, excuse me. All right, and let's look at B, male or right-handed. Now, male or right-handed, you have to be careful with this. So male is going to be this and this, but you also have to count the female right-handed. So 32, that's 48, and that's going to be 56 out of 60. Okay? And then right-handed, given that the player is female. Okay, so this, again, is conditional probability. So let's look at female here, and right-handed, so that's just going to be 16 out of 20. So you notice in conditional probability, the denominator is always getting smaller there. That's all you have to remember about it. Okay, now we're going to go on to independent probability. Okay, for independent events, you will always need to multiply the probabilities. Be careful if the problem is a replacement or non-replacement one. Remember that when 2 things are chosen simultaneously, like marbles or names from a hat, it is equivalent of using non-replacement. So when you use non-replacement, that means that the numerator and the denominator are going to get smaller by 1 the next time you do it, usually. Okay. Well, the denominator for sure by 1. Let's do a couple problems. A bag contains 3 red, 4 yellow, and 8 green sweets. Eugene chooses 1 sweet out of the bag at random and eats it. Then she takes out a second sweet. Write down the probability that the first sweet chosen was red. Okay, well that's easy. There's 15, and that's 3 out of 15. That's no big deal. That's simple probability. Given that the first sweet was not red, find the probability that the second sweet is red. Okay, well, again, this is conditional probability. She took one out and she ate it. It was either yellow or green. So there's still 3 red ones left, but at the end there's only 14 because she ate one of them. Now, this is what I'm more concerned with here. Find the probability that the first and second sweets were both yellow. Okay, well, there's 4 yellow sweets, right? So when she grabs the first one, the chance is 4 out of 15. And then you need to times it, or multiply it by times it. What am I, in 2nd grade? It's not 15, it's 14. Okay, so that would be, find the probability that first and second sweet chosen were yellow. Yeah, so it would be 12, and then this would be 210. Okay, so yeah, just sorry for the delay there. Not that there was much of a delay, but just realized I made a mistake on my answer sheet I gave my kids. That's not good. Okay, there are 2 biscuit tins on a shelf. Okay, this one we're going to use a tree diagram, which is good. Okay, the red tin contains 4 chocolate biscuits and 6 plain biscuits. The blue tin contains 1 chocolate biscuit, 9 plain biscuits. A child reaches into the red tin, randomly selects a biscuit. The child returns the biscuit to the tin, shakes the tin, then takes another biscuit. Okay, that's gross, but that's all right. So draw a tree diagram that show the possible outcomes, place the appropriate probability on each branch. Okay, so we're talking about the red tin here. So what are our choices? We have, chocolate, and we have plain. Okay, so how many chocolate are there? There's 4 chocolate and 6 plain. So probability of a chocolate is 4 out of 10. Probability of plain is 6 out of 10. Now, the kid puts it back for some reason. I've never seen a kid put a biscuit back, but, you know, whatever. 4 out of 10, 6 out of 10, and then 4 out of 10, 6 out of 10. So this is basically non-replacement probability. Okay, and so we got, no problem, we got that done. Boop. Find the probability that both are chocolate. Okay, well, we'll just do, I should have written chocolate, plain. So we just go chocolate, chocolate, which would be, you know, 4/10 times 4/10, which is 16 over 100. Okay. And then part 2, one of the biscuits is plain and the other biscuit is chocolate. Okay, this is where they try and confuse you a little bit. So what one biscuit is plain is the other is chocolate. Well, we're going to have to add 2 probabilities here. We can have chocolate plain plus plain chocolate. Okay, so, you know, we'll just go, I'll move it over here a little bit. 4 over 10 times 6 over 10 plus 6 over 10 times 4 over 10. And that's just going to be, you know, 24 over 100 plus 24 over 100, which would just be 48 over 100. So that's where you're adding 2 probabilities together. Okay. Now, a second child chooses a biscuit from the blue tin. Okay, what do they have? Blue, 1 chocolate, 9 plain. Okay, no problem. The child eats the biscuit. Okay, that's more like it. They're more likely to eat it, I think. And chooses another one from the blue tin. Okay, no problem. The tree diagram represents the possible outcomes, the event. So write down the values of A and B. Okay, well, okay, so let's do this. 1 chocolate, 9 plain. Well, if they eat a chocolate, there's going to be 0 left. There's going to be 0 out of 9. And then this would be 9 out of 9. I just like filling in the whole thing. I think it's easier. If they eat a plain one, it would be 8 out of 9. And then this would be 1 out of 9. So, you know, A equals 8 and B equals 9. Okay. Now, find the probability that both biscuits are chocolate. Well, there's only one biscuit, so both biscuits can't be chocolate. So that probability is 0. At least one of the biscuits is plain. Well, again, you know, look, this one, this probability, chocolate plain, plain chocolate, and plain. Those are all, since you can't have chocolate, it has to have one biscuit that's plain. So the probability there is actually going to be 1. Now, suppose that before the 2 children arrived, their brother randomly selected biscuit tins and took 1 biscuit. Calculate the probability the biscuit was chocolate. Okay, now this one, okay, you have to, whenever they say randomly selected, okay, so we have the red tin and we have the blue tin. So randomly selected means that there's a half probability of taking each. Now, for the red, we have to do what's chocolate and plain, and chocolate and plain. So for the red one, it was what, 4 out of 10 and 6 out of 10, and this was 1 out of 10 and 9 out of 10. Okay, so, you know, calculate that both biscuits are chocolate. Okay, no problem, we can do that. So we'll just do, you know, 1/2 times 4/10 plus 1/2 times 1/10. So that's, you know, 4/20 plus 1/20, so that's going to be 5/20. And there you go. Okay, so that's a tree diagram problem. That's a pretty good one because it has independent probability. It has replacement, not replacement. Not bad. All right, let's do one last problem. One more. Okay, this last problem, it says a group of 50 students completed a questionnaire for a mathematical studies project. The following data was collected. 18 students own a digital camera, iPod, 15 iPod, 26 own a cell phone, 1 owns all 3, 5 owns, okay, digital camera but not a cell phone, 2 owns a cell phone, iPod, blah, 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 blah. Okay, no problem. Represent the information on the Venn diagram. So let's bust out a Venn diagram here really quickly. Okay, so remember you have your universal set here, and we have 3 horrible circles as always. And let's see, D, digital camera, I would be iPod, and C, cell phone. Okay, no problem. Let me switch up some colors here so we can see what's going on. Remember, always work out, so one person owned all 3 items, so 1 right there. 5 people owned a digital camera and an iPod, but not a cell phone, so 5 is going to be right there. So this is actually a pretty easy Venn diagram. You don't need to subtract. 2 owned a cell phone and iPod. Okay, so that's, but not a digital camera, and 3 people owned a cell phone and digital camera. Okay, so that's right there. Now, 18 people owned a digital camera. Well, that's 8, 9, so that's going to be 9 right there. How many people owned an iPod? 15, so that's 7, 8, so that's going to be 7. And then 26 owned a cell phone. Okay, well that's 6, so that's going to be 20 right there. Okay, and you know, let's see, that's 14, 21, 22, 24, 27, and 47. So that means 3 didn't own anything at all. Okay, so let's look at some of the rest of the problem. Hold on just 1 second. Okay, so part B here says calculate the number of students who own none of the above items. Well, we already did that. We subtract all of them from 50, so that's going to be the answer there is going to be 3. If the student is chosen at random, write down the probability that the student owns a digital camera only. Well, that's 9 right there, so that's just 9 out of 50. Now, if 2 students are chosen at random, okay, this is independent probability. Calculate the probability they both own a cell phone only. Okay, well, that would be the first student would be 20 out of 50. Now, assuming we choose the first student, then the next one would be 19 out of 49. Okay, and if you did that out, you would get, let's see, 380 over 2,450, and you can just leave it like that. Now, this one's conditional probability. If a student owns an iPad, or iPod, why do I keep saying iPad? I don't know. Write down the probability that the student owns a digital camera. Okay, so we're only talking about an iPod, not an iPad. Okay, so I've got to remember that some of these questions are pretty old. Okay, now, so how many are there? Let's see, we have 12, 15, and that matches right there. So 15 is our denominator. And own a digital camera. Well, this person, these 5 people do, and this one does. So that's going to be 6 out of 15. And you're good to go. So anyway, I get that this is a long part on probability, but you know, I tried to give you as many examples as I could. And you know, independent conditional probability. Just be careful with replacement and non-replacement. Remember, you have to lower the denominator. You may or may not have to change the numerator. It just depends. And, you know, you should be good to go. Hope this helped you out. Take it easy.